I'm Greg Saline, a master's math student at YSU. This project is for my final project for getting my master's degree. And the purpose of this video is to demonstrate the code that I wrote. I'm writing a Picross style game, and it's to accompany my paper where I explain how the game works and the drawbacks, the problems I encountered along the way, the things I would improve in the future. This video is just to give context to all the different things I'm talking about in the paper. So yeah, let's get started. Here I'm running the code. A Python Turtle Graphics empty window pops up, and it says, "Welcome to Nonograms." It explains what nonograms is. It's a Picross puzzle game. The objective is to correctly fill in the grid according to the clues. Spaces will be empty or filled, and when all the squares are correctly set, you will have won. In a typical Picross game, you're trying to reveal an image. However, in this version, the answers are random. There are 4 difficulties: easy, medium, hard, and very hard, which determine the size of your grid. Once the window pops up, use the numbers along the top and the left of the screen to tell you how many spaces to fill. You will click on each of the squares to set them as blocks or X's. You will also be able to type X on the keyboard to switch between laying blocks or laying X's. Before we begin, though, we need some information from you. To begin, enter an integer to represent the number of levels you'd like to play. Today, we're only going to play 1 level. Then, you've chosen to play 1 levels. Now that you've selected the number of levels, the next thing is to select your difficulty mode. There are 3 difficulty modes in this game the way I wrote it. Random difficulties, it will choose randomly for however many levels you've chosen, it will randomly assign these difficulty levels. Then there's increasing, which is self-explanatory. The levels will get harder as you go. So if you opt for, let's say, 8 levels, you'd get 2 easy, 2 medium, 2 hard, and 2 very hard. And then finally, pick difficulty per level. This is the one we're going to select today, where you, as the user, get to pick which difficulty level you want. I'm going to pick easy for the sake of this demonstration. Pick difficulty level. And then this is the optional part that pops up. Begin with level 1, you have 4 difficulty levels. Let's type E for easy. Now, the turtle screen pops up again, and we can start. As explained in the directions, you can click on the screen to place blocks. See down here, this is what I called the switch. And typing X on your keyboard switches the switch from placing blocks to placing X's. Blocks are used when you know for sure that space is to be filled in, and X's are used when you know for sure that that cell should be empty. I'm going to begin with the switch set back to block, and I notice right away there's a 5 here. So that tells me that this column definitely has 5 blocks in it. So let's fill it in. You'll notice as well that the turtles do this little celebration when you get a cell or column right. Now, the next thing I notice is that this row has 3 in it. 3 that are connected. So because I already have this 1 filled in, I know for a fact, like the 3 could go here or could go here, but I know for a fact that the 3 must connect to this block. So I know that this and this should be filled in. Now, one thing you'll notice about this puzzle is that the X's automatically got filled in. The motivation for this game was a game I've played on my iPhone called nonogram.com. And in their version of Picross, that feature is also present, where one does not have to fill in the entire row or column in order for it to register that the column or row is successfully completed. In other words, you only need to fill in the blocks, and it will fill in the X's for you. Okay, that was a hard feature to implement in my program, but I eventually made it work. So where am I going to go next? Well, the next thing I notice is that this column has a 1 followed by a 1. What that means is that the 2 blocks are not sequential. There's a break between them of at least one x. So I'm going to switch and place an x here and an x here. Let's see. Now I know this row has 1, 1, and I've already got a 1 placed with a break. So that means the final one either lives here or here, but I'm not sure which, so I'm going to hold off. Let's see. Maybe you, viewer, see what I should do next, but I don't yet. Let me think. This row is 1 with a break and a 1, so that means there must be at least one x before this. This row has a 1 break 1, so there must be at least one x before this. And that tells me that the fourth column here must have a 1 right here, which finishes that column. Now I just noticed this row has 3, and I've already got 2 of them, so this must complete the column and the row. Let's see. Or the row and the column, I should say. Boom. Okay, that's nice. All right, now this column has 1 in it, but we don't know where. This column has 2 1s in it. Now let's see. Okay. One of the 1s has to live up here. There's a break, and the other one has to live down here. So I know for a fact this is a 1. Let's fill it in. Perfect. Okay. Now, what does that tell me? In this column, I've got a 1 somewhere. In this row, I've got a 1 somewhere. In this row, I've got a 1 somewhere. This is the point where you just have to guess. So I'm going to guess that this is my 1. Okay, I guessed correctly. But I didn't know which of these 4 spots it was in, so I was just going to guess. I could have gotten it wrong. I kind of wished I'd gotten it wrong. If you'd gotten it wrong, the way that this works differently is actually, let me get the last one wrong to show you. I know for a fact this is a block, but I'm going to place an X instead. When you incorrectly place something, you get it fixes it for you, and it becomes red. So let me show you. So there was me incorrectly placing the X, which they changed to a block. Notice how it got larger for a second, and notice as well that it kind of paused. That's what it does anytime you incorrectly place either a block or an X. It gets placed, it gets larger for a second, and then shrinks back down, and it's the correct item in the spot. In other words, like if I had incorrectly placed an X here, for example, it would also get large for a second and become red and become an X. Notice as well that my life counter decreased. If my life counter decreases all the way, I get 2 choices. I get to either replay the exact level like it is, or with 1 less life, so it like kind of restarts, or I get an opportunity to play another level of the same difficulty with all my lives. In other words, if I were to have failed this level by losing all my lives, I would be given the choice to replay the exact same level with 2 lives instead, or replay a new 5x5 with all my lives intact again. Now, one drawback of my program is the fact that you have to keep jumping back and forth between the terminal down here and the actual game board. But we got the message that we won, which is the message you receive when you win 1 level. We also received the message you beat all 1 levels, because we set the game to only play a maximum of 1 level, so we only played 1 level. But that is the walkthrough of my video. I hope you have enjoyed it, and I hope it clarifies some things in the paper that I will be presenting. Thank you for your time.